Hello and welcome everyone. I'm your host Stefan Burns, geologist, geophysicist, space weather guy, cosmic bro. We have a big situation right now. It's actually not that big, but it is interesting and we're going to talk about it so you can learn more about the Earth geophysical energy system. We could have a big situation coming in. We just had a quadruple burst of solar activity from 3 separate sunspot groups back to back to back, which is quite interesting. You see sympathetic activity sometimes. It's not that common. This time it's really distributed. Usually the sympathetic activity where 2 spots flare at the same time, they're kind of close together. They can be linked together. This is across the entire Earth-facing side of the sun right now that we're getting some significant solar flares. We've had 3 M flares in just about 8 hours or less. I mean, more like 6 hours. A 1.3 M flare, a 1.3 M flare, a 4.2, and then also a 2.2 M flare. And the bigger story here is that Earth's radiation belts are fully charged. So we have this body of plasma that surrounds our planet. We call them the radiation belts, also the Van Allen belts. These are made up of super highly charged particles, very, very highly charged. You wouldn't want to fly through them. You need pretty extensive shielding to fly through the radiation belts on like a space mission as they are right now. If you happen to fly through them when they're fully depleted and decharged, like we may have coming up very soon, because it looks like the sun just launched a solar storm our way, then you can go through them effectively unscathed. But high energy particles, if they hit you, they're creating cellular damage, single or double DNA strand breaks. You know, astronauts in space, they'll close their eyes, and if there's a lot of cosmic flux happening, they will even see little flashes of light from those high energy particles hitting their retina, and the brain then registers that as a flash of light. So this is serious energy surrounding our planet. Very little mass. There's almost no mass in terms of, you know, the actual weight. You were to group all these particles up and put them in a bottle, it's not that much. But there's a tremendous amount of energy to them because they're traveling near the speed of light. In fact, the radiation belts are a natural particle accelerator for the Earth. And right now they are fully charged. As charged up as they can get, basically. Very rarely will we see them more charged than this. This is just an animation showing you the radiation belts. Let me show you how charged they are right now. Here they are, okay? So this is our real-time view. This is December 25th. It goes all the way up to today. We see our flux level here. You can read the measurement values if you want. But this is fully charged for almost a week now. Here we see our magnetic field. And so this is something that occurs after you have significant and sufficient solar wind and solar storm impacts, which we've had over the past couple months. We've had a lot of these over the past couple months. So now we have fully charged radiation belts. Let me show you what has happened with the sun. We'll get back to this. We'll learn a little bit more about ion precipitation events, because that's what we call this, okay? But here we have our sun. This is this quadruple sequence, okay? So you're going to see a flash at the very end. But here we go. We have our first flare, second flare, third flare, and then our fourth flare just occurred. So here it is. 1, 2, 3, and then 4. This one, you'll notice, is actually pretty sizable. That's that 4.2 M-class flare. Look at how it launches out this coronal mass ejection really nicely. It's not that far off from Earth direct center, which is right here. So this is possibly going to interact with the Earth. I think it's likely that we get hit by that, not maybe directly, but I do think we have something coming in as a result. So that just happened. That was about, let's see, 22:30 p.m. Universal Time on the 28th. It's now about 4 a.m. Universal Time on the 29th of December. So this occurred just about 6 hours ago. And in fact, right before this big burst of activity, let me show it to you on the X-ray flux, because you can see the peaks really nicely with the data. It's quite interesting. Let me show you this. I had just, and watch my cursor, okay? I had just gone to the gym. And so halfway, more like a third of the way through my workout, all of a sudden it's like, so fatigued. I was like, why is this so difficult? I'm not that out of shape. And then I finished up my workout. I don't check my phone when I'm at the gym. I was walking back home. I was like, I bet there was a solar flare. And it was all this, my bout of fatigue, you could say, which was like 20 minutes and then it went away, was right in this zone right here. And then the big flare occurred. So it's almost like a preemptive effect, which was quite odd. And it's not common for me to feel the effects of this solar activity, but this is a big sequence right here. There's that 1.3 M flare, there's our 4.2, and then our 2.2. This is a high C-class flare right there. So this whole thing taken together is quite significant. Again, if we watch it on the sun here, you'll see it's across the entire Earth-facing side. So the Earth got pelted with radiation and high-energy light photons 4 times now. From this, we can look at our radiation, we can look at our DRAP model to see the impact on the ionosphere. So let's pull that up. And I'm glad I remember this. So here we have that. And this shows us effectively where these light photons from these flares are coming in. So that's the first one, second one. There's the 4.2, right? Much bigger, right over the Pacific Ocean. Pacific's very, very conductive. All the oceans are very conductive because of all the dissolved salts. And there's that last one. So this just, oh, actually, no, that's the third one. And then we get our last one coming up here near the end. And you'll see it starts to go more over Asia at this point. So just wait a moment and you'll see that occur. Boom. And then it's going to reset right here. So 4 significant flares now, a high C-class with the last one, 3 M-class flares recently. Again, we'll see this mostly hitting the Pacific. And that's charging up the planet. And that's where we've been seeing a tremendous amount of activity earthquake-wise. Taiwan with magnitude 6 and 6.6 earthquakes. Japan, we had 6.4, 6.8. 7.6, 6.7, 6.6 earthquakes, tons of magnitude 5s and 4s. We've also had tons of earthquakes around Tonga, magnitude 5s, around Guam, magnitude 5s. Don't forget that we had a big earthquake in the Philippines not that long ago, a couple months ago. Maximum, that was like a 7.6, I think, something around there. So there's been tons of activity in the Ring of Fire, more so than elsewhere. And when you get these ion precipitation events, it can be pretty significant. So we can go back to that. So here we see it starting off, okay? So there's the data starting off, and you see that we basically just hit this full charge going all the way up till today. This doesn't deviate at all. So for a week now, we have been really fully charged with our radiation belts. And it's inevitable at this point that we have an ion precipitation event because if they're fully charged, at some point they are going to decharge, and they don't do it slowly, they do it quickly. So let me show you the data for that so you can see what I'm talking about in a different sense. Here we see our electron flux going up and up and up. This is measuring particles per cubic centimeter per second. You notice this is a logarithmic scale. So these are big jumps, okay? So when we have a geostorm and this washes out and there's a big precipitation event, it'll go down to here, 10 or 100 particles per cubic centimeter. It kind of ranges in there. More like 10, 20, 30, 40. Right now, it's up to 10 to the 4. So that's 100, that's 1,000, that's 10,000. We're reaching values on the daytime side, right? This is midnight for the 2 different probes, they're geostationary, so they pass through their midnight, the darkest side, and also the noontime, the most bright aspects at different times. But we see that for our noontime, when they're in view of the sun, on that sunward side, there's a ton of these particles in our radiation belts, 10,000 plus of them. And then it's decharging at night. When these things pass into the nighttime side, you see that the radiation belts have an imbalance in their charge, but still just below the warning threshold. So it's not that far down. This is like a supercharged radiation belt setup at this moment in time. And if we look at our sun, we saw that sequence, but let me show you the sunspot activity because we've been having significant sunspot activity. So here we have that. Check this out. We have our intensitygram for today. This is about the past 26, 27 hours, something like that. This sunspot group right there has been really active in its development. It hasn't really done any significant solar flares. This is sunspot cluster 4321. And it's by far the biggest group on the disk, the most compact, still exhibiting growth as it rotates off. It has been active starting right here, basically burst out of nothing and then transited through. Well, Earth, of course, is on the Earth direct line. 3i Atlas is about 40 degrees off from that line right now, so it's right about here. So it's interesting, and 3i Atlas, the interstellar object, is also slightly below the ecliptic plane, just barely. Guess what? This is slightly below the solar equator. So as this thing has moved from the Earth through that alignment with 3i Atlas, it's been, growing tremendously. But here's where we had our flare sequence just over the past 8 hours. We had the burst down here, and then we had the 4.2 right there, and then this one's been active. And this guy's been on the sun for more than one rotation now. It's given us multiple X-class flares. We're likely just seeing the beginning of something with this solar activity. It's probably going to continue to increase. At the end of the day, 4.2 M-class flare isn't that big. It was a fairly nice sequence, launched something out into space, it had a coronal mass ejection, coronal dimming, all the things, but it's a 4.2 M-class flare. It's not a 4.2 X-class flare. It's not a 14.2 X-class flare. But these guys have been active. This one, look at the growth on this sunspot group right there, just over the past, this is like just 24 hours right here, right? It's going from effectively nothing to quite large. So it's regrowing because this sunspot group there did exist when it rotated off 2 weeks ago, and then it seems to be returning now as it's entering into this alignment with the Earth and also Jupiter. Jupiter right now is behind the Earth exactly. It's this planetary alignment that we've been talking a lot about on the channel. Earth and Jupiter having big magnetic fields, the biggest magnetic fields in the solar system up to the distance of Jupiter. Mercury's magnetic field is 1/100th the strength of Earth's. Venus doesn't have a magnetic field, only induced. Mars doesn't have a magnetic field. Only Earth and Jupiter have significant magnetic fields out to 5.2 astronomical units, which is the distance to Jupiter. So we see these connections electromagnetic between the planets and the sun. If you track it closely, you can kind of see how that affects sunspot development too, though that's also based off of gravity and more. But this triple flare sequence now, it's actually more, it's like a quadruple flare sequence across the sun just in the past 8 hours. Let's watch that again. There's that 4.2, and then this is the one that's now picking up the activity. So it is really quite interesting to see it spread so far out across the sun, showing that just in general, the sun is active, right? It's not just one sunspot group that's showing activity and the rest are slumbering. The entire Earth-facing side is showing activity. That's a bit of a clue that this planetary connection has some merit to it, because they're going to influence, if there is a gravitational and or electromagnetic influence from the planets on the sun. And gravitationally, there for sure is, okay? Electromagnetically, I think there is as well. We need more data, but we can look at actual observational evidence to make, kind of support what we do know before we have all these super rigorous studies, because we really haven't been looking at this for that long. We have our first good visual measurements of the sun starting with Skylab in 1973, similar to this imagery here. So it hasn't been that long, like 50 years. It's probably too short of a time frame to make any definitive conclusions. But if there was an effect between the planets and the sun, well, Earth and Jupiter would be the key players with their magnetic fields if it's electromagnetic in nature. And they're in alignment right now, and we're seeing this activity not just from one sunspot group, but from all three of them. So it's very quite interesting. And this group right there is now starting to flare again. So I think we have a high likelihood of high M-class flares and even X-class flares going forward for the next 10 days as these rotate across the Earth-facing side. That is my official forecast for you. And I think we're going to get some activity around that planetary alignment January 6th, 7th, 8th, 9th, 10th. Hard to say exactly when. It's already taking shape right now, but we do have that. We also have some coronal hole activity on the sun. So let me show you that. Here we have our 211 angstrom view colored with the 193 angstrom filter. It just looks a little nicer. We see this large coronal hole that has been active on the sun for a while. It stretches out to beyond the far side. Here we have this we have this large coronal hole that's exactly Earth direct right now, close to the equator, but definitely skewed to the northern hemisphere. So it's uncertain whether we're going to have a high-speed stream impact from that. I think it's likely we get a little bit of something from that. That's what NOAA is estimating. But that is going to come in about 2 to 3 days because it needs to go geo-effective, which is right about this degree mark, longitude mark on the sun. So it's not there yet, but we see this connection. Longtime viewers know that there's this connection between coronal hole high-speed stream impact, solar wind density, and high-magnitude earthquakes on Earth. So we could be looking at some significant earthquake activity once this goes geo-effective. Basically, we've been having significant earthquake activity already. So let's check that out really quick because this is all connected. Here we have our past 7 days, and let me filter this for largest magnitude first. Here we see Taiwan. This was on the 27th, so just yesterday. 27th Universal Time, December 27th, and this is UTC time. And during that video, we had this quake occur, and we looked at the antipode location for that, and I said, guys, there's a higher likelihood of there being a quake near that antipode. That is significant. Well, someone pointed out to me, and I actually saw this quake, but someone pointed out to me that in fact before that 6.6, notice the time there, 1505 Universal on the 27th, we had this 5.6 at 1040 Universal on the 27th, and that is almost exactly on that antipode. So we had that quake as a precursor antipodal quake to the magnitude 6.6 in Taiwan, and then at the time I made that video, I forgot to mention that 5.6. I did see it, but it slipped my mind, but I gave a forecast for there being an antipodal quake being more likely after that 6.6 and being in that magnitude 6 range, because if it's a magnitude 3 quake or 4, even 5, it's like, okay, it could have just been random. It's got to be kind of similar magnitude. Well, that's what we got. We had this 6.2 follow-up in Peru. Similar depths for both of them. 66.4 kilometers there. Taiwan is 67.5. So that's interesting. Now, if we go to our antipode map, this is these aren't exact antipode locations, okay? But let's type in Taipei, Taiwan, because that is effectively that earthquake occurred right near Taipei. We see how this cuts across there, across the globe, goes down to Argentina. You see how close that is to that 5.6 precursor antipodal quake. It's almost smack on, and it's not on the main subduction zone. So that's a little unusual to get a 5.6 in the middle of the South American continent, whereas the forecast I put out for a high magnitude quake following that 6.6 was along the subduction trench. And well, we had it up here. So not exactly on the antipode, but if you look at it in the grand scheme, pretty darn close. If we move this around, we can see it's not that far off. It's right about here, right about there or so. So not that much of a deviation from the exact antipode for Taipei. So those are clearly connected together because they occurred after each other. In fact, we had a triple sequence. We had the 5.6, the 6.6, and then the 6.2. So when Earth is supercharged, and then you have these radiation belts precipitate down, that charges the global electric circuit, and the global electric circuit is an important component of overall earthquake activity. And as I mentioned earlier, look at the skewing of activity along the Western Pacific, and that 6.2 is the only thing holding up the Eastern Pacific, right? There's been so much activity in the Western Pacific this year, and actually for multiple years now, as compared to South America and also California. We did have that magnitude 6.8 Hubbard Glacier earthquake not that long ago. That's up here, so that's getting closer over, right? And we get quakes in Mexico, but in general, North America has been quiet. South America in comparison has been quiet because we've had magnitude 7s, magnitude 8 megaquakes up here this year. It's been one of the strongest years of seismic activity ever recorded. So what is an ion precipitation event? Let's just talk about that, learn a little bit more about this space weather phenomenon that occurs at a fairly regular cadence, but when the radiation belts are as charged up as they are now, it is notable, which is why we're talking about, especially when you pair that with the incoming solar activity, with the planetary alignment, with the fact that we have an interstellar object in our solar system with its own unique vibration and resonance that's different than our solar system, spewing out gas, dust, and plasma all over our interplanetary space. Like, there's just a lot of things that you just put them all on a list and you start to look at them all, right? You can't be reductionist with this. You have to look at this holistically, like, okay, this is like pretty serious. We also have a Saturn-Neptune conjunction right now. So strong space weather impacts trigger geomagnetic storms, meaning new and enhanced energy flows throughout the plazosphere. This squeezes the radiation belts, which causes ions to rain down into the ionosphere. And we see that graphic of the precipitation going here. The reason why it looks like this is these high energy particles are traveling so fast, they have so much energy that they will hit a molecule or an atom or something, and they'll instantly ionize it, such that it becomes a super high energy particle, and it creates these particle cascades. So it's not just this thing goes down and boom, that's it. A single particle can energize, and as a result, thousands of particles or molecules. So again, there's not that much mass up there, there's not that much plasma up there, but so high energy because it's traveling so close to the speed of light. The closer to speed of light you get, it's like exponential on the energy uptick. So these are super high energy particles. They rain down, they charge up the ionosphere. We see that off here on to the right. We see how the ionosphere conductivity, aka the electron density, changes from normal conditions to elevated conditions like during a geomagnetic storm. And there's differences between the daytime side and the nighttime side. It's more conductive on the daytime side, less conductive on the nighttime side. But regardless, during a geostorm, you will get enhancements in this. We can look at our other graphic here as well. And here we see the plazosphere charged up. That's what the model looks like when it's charged up. And again, if I show you what it is right now, it's well beyond that, okay? It's this dark red color. I can even go forward a little bit to show you closer to right now. This is where it is right now. It's supercharged, okay? So I pulled, this is like a high flux picture that I grabbed back when I made this graphic, September 23rd, 23. Right, it's way more charged up now. Here's what it looks like low charge, very low flux. So it has these very cool colors, the flux is very low. When Earth's magnetosphere is crunched by space weather like solar wind changes, solar flare, photon bursts, coronal mass ejection, solar filament impacts, etc., ions of Earth's plazosphere are energized and reorganized. The changing plazosphere, or the changing plasma flows, send a lot of highly energetic plasma ions from the magnetotail into the radiation belts and ring current, and these ions eventually rain down into the ionosphere from those parts of the plazosphere. Alterations of ionospheric electromagnetic potentials drives changes to the global electric circuit, which influences geophysical energies we biologically connect to, like telluric currents and Schumann resonances, because there are electric currents flowing through Earth's surface all the time. These are known as telluric currents. They are in resonance with the sun and with the lunar phases. They are also enhanced during geomagnetic storms, especially very strong solar wind impacts. Now, what drives these particles to crunch down and precipitate into the ionosphere, right? They're headed towards the surface of the planet. It's because they enter into resonance with Earth's magnetic field. So there are wave-particle interactions, and what happens is normally you have these particles kind of zooming around the magnetic field of the Earth. They're accelerating, they're accelerating, they're accelerating. But when you have a big push on Earth's magnetic field from a solar storm, that changes the property of the magnetic field. And now these particles are routed down to the planet. So they follow the magnetic field, force field down. And that is technically taking them to the surface and actually to the core, but they interact most of the time before that. Some of them, of course, are going to reach the surface just because they don't have a probabilistic interaction on the way down. But most of them, like 99.99 whatever percent, are going to interact in the ionosphere. So they are going to go straight down and then create those particle cascades. That charges up the ionosphere, has an electric potential, an equipotential typically of 250,000 volts, 250 kV. Earth's surface potential is 0, and it is that difference in the potentials that drives this current of energy in between them and the overall global electric circuit. And so when the ionosphere gets all these new particles flowing in from the plastosphere, its equipotential goes up to 300,000, 400,000, 500,000 volts, and that electric current strengthens. That electric current now is also piercing deeper into the Earth. It's not going just to the surface. This is going all the way down to the more conductive, deeper layers of the Earth as well. So that's passing across fault lines. That's passing through magma chambers of volcanoes, like everything. So we can't look at these geostorms and every single time one comes in saying, okay, we're about to have a burst, like a huge burst of volcanic activity, or guys, get ready for the mega quakes. It doesn't work like that. It's not a 100% guaranteed thing, but it does seem to add more volatility, more energy into the system, more volatility into the system, and these sort of high intensity events are more likely. So there's no like exact this is what we got, but it is okay if we have this coming in, we can say it's probably 20% more likely or something like that. You can just start to look at it's more likely than not. And the normal space weather forecasters, they never talk about this stuff, so they're not going to tell you that. But if you look at the data, and we have on this channel across more than a year now, like multiple years now, I've been really making videos since 2023, is we see these events clustering in time. Especially with like coronal hole high-speed stream impacts, but we sometimes see big earthquakes during geostorms, perfect timing with like the onset of the storm and then boom, the big earthquake. Or it's like the strongest part of the geostorm, because there's different aspects to a solar storm impact. There's a shock wave kind of aspect where you get the initial hit. That can be quite jarring to the magnetic field, the plastosphere. But then as it goes on, the actual magnetic volatility will build often. And sometimes that's when things are the most volatile, that we see events. And then there's also long-term changes that results from these sort of solar storm impacts. Because, for example, what we're seeing right now with the belt supercharge is a common effect of a bunch of solar wind and solar storm impacts. So you can see these long-term changes in our radiation belts for weeks to months after a very big storm, like a severe to an extreme geomagnetic storm that's G4, G5 levels. We can see not only a 2-belt structure, but 3-belt, 4-belt structures. They change in their position away from the Earth, their flux density, the ion, the actual types of ions. During a geostorm, you get oxygen to come into the plastosphere. You may see enhancements in helium, oxygen, even like iron. So a lot of diverse changes that occur in our energetic environment immediately outside of the Earth from the effect of the sun and space weather and solar flares and coronal mass ejections and all that and more. So that is what we have happening right now. One more thing to show you is our coronagraph imagery. So let me pull that up. Have it right here. And our coronagraph is showing us something quite fascinating, something we only see once every 6.6 years. We have Venus. We have Mars. That is not a star, that's Mars. You'll notice it's moving slower than the background sky. You see the center of the galaxy there. So this is the galactic center. Here's our sun. They put a little disk over it so we can see the corona. It's much, much, much more dim than the main body of the sun, which is why we need to put that occluding disk over it. But this allows us to see the outflows from the sun as a result. We only get these sort of triple conjunctions. They're actually quite rare. These sort of Mars or Venus, Mars, Sun conjunctions occur every 6.6 years, but sometimes they're not exactly with the sun. Sometimes the actual conjunction will be a bit more offset. This one is occurring exactly with the sun. So we have Venus first go Cazimi, and then we had the Venus-Mars conjunction, and then Mars goes Cazimi the next day. So it's a back-to-back-to-back sequence, and that's all with Jupiter in opposition. And last time, one of the times we saw this, back in 2006, last time it was kind of similar to this one, which was pretty precise. The two before that, which would be 2019 and 2012 or so, those ones weren't as closely aligned with the Venus-Mars conjunction being with the sun. 2006 they were. We looked at that data, and we noticed that right after they come in, we get this increase of solar activity. Let me actually play the clip for you, okay? So let me pull that up, because this is I could see this happening. I could see this happening this time. I could see things effectively being a repeat here. So we have Venus, we have Mars, we're also going to see Mercury and Jupiter appear. In 2006, we had Jupiter on the other side. So this time we have it behind us. Last time it was precise like this. We had Jupiter on the other side. Watch though, first, okay, so before I start, look at the sunspot number in October. It's less than 15. Look at where it was in December. Now it's 60. This was near the very end of the descending phase of solar cycle 23, nearly solar minimum. And we had this quadruple increase in sunspot numbers. And it started after this conjunction between Venus and Mars with the sun. So you'll notice how the solar activity will start to build up after that. We don't really have much, and then you start to see some faint full halo coronal mass ejections get launched off. Right around there, there's the first one. We see another one coming up. We start to see more activity now. There's another, right? We get a comet flying. There's a coronal mass ejection that launches off. Check out now the activity really building with Mercury as it does its Cazimi. Now, as we get this Jupiter-Venus conjunction and we then get Jupiter-Cazimi, we start to see big activity come off. Those are sunspots on the limb. 7 days later, they're Earth direct, and we get two big solar storm impacts. There's the first one, and then we get another one to follow up afterwards, and that is right there. And there's our galactic center at the end, because this is October through December. So it's a little bit further in and closer to the galactic center this time. But again, you see that things are quiet. Right, this is nearly 2 months of data here. Things are quiet, then we had the sequence, and then things started really building up. Near the very end of the descending phase, sunspot numbers quadrupling during this time period. So this is not guaranteed that we're going to see the same thing this time, but this is almost an identical setup other than the fact that Jupiter's on the other side in this one. That's a superior conjunction for Jupiter rather than an opposition right now. And this is also during the descending phase. Right now, we're at the boundary between solar maximum and descending phase. Let me show you the sunspot numbers. I haven't shown you that in a while. Let me pull that data up. Our solar cycle progression data here, because this is good to see. So here we have our solar cycle progression, and I will zoom this out there for solar cycle 23. Here's solar cycle 25, stronger than 23. Not tremendously stronger, but stronger. Definitely back there. I think that's what, August? August of 2024, big month for sunspots. I remember that very clearly. We're over 215. I think it's 216 for our monthly average. Yeah. This is where we've been recently, having these drops and rebounds, and then November was higher than May was. November was 91.8. May was down there at 78.5. But December has had more sunspots than November. Right now we're around 150 or so. So I think December is going to be a bit higher. We can turn off all these percentile ranges. They just clutter up the graph. But you'll notice that we are still in this overall kind of plateau region. You see that with solar cycle 24 right there. Once you're really going down the slope, that's the descending phase. We're at the boundary right now between the descending phase and solar cycle. We're right now at the boundary between solar maximum and the descending phase. We zoom out to include 23. We see that clearly. There's kind of this zone right there, right? That's the maximum, 2.5, 3 years long. same deal right there. And then once you kind of break down past that level that was part of the ascending phase, now you're clearly in the descending phase. We're not there yet. We're still right at that level. So that's probably going to occur in, I'm thinking February, March, April of 2026. I think we're going to start going down in sunspot numbers and probably ride it out for a while, just like we saw here and here, but we're not there yet. So the Earth has been charged up a lot because of solar maximum now, right? If we go back to here, this 2023, 2024, and 2025 has all been high activity. 3 years of charging now. That has an influence over the bigger systems. No surprise that we had the magnitude 8.8 megaquake. No surprise that we had Haley-Gubi volcano erupt in Ethiopia, first time in 10, 12,000 plus years. We don't really know. Mount Etna is erupting right now with some pretty big activity. We had a pyroclastic flow at Mount Merapi. We've had tons of activity at tons of volcanoes. The Kamchatka Peninsula, where we had the magnitude 8.8, all the 7s and 6s and 5s. There's tons of activity there. Krishenikov volcano, first time in 600 years, it's woken up. Mount Semeru and tons of activity in Japan, and I could just go on and on and on. So there is something to this, and we are kind of at the final phase now of this solar maximum. And this planetary alignment, I think, is likely to bring things back to kind of like the final, perhaps, big show. Like there's at least that possibility in January. And maybe this is a preliminary sequence to this. Because again, we just see how distributed this is across the entire Earth-facing side of the sun. It's not just from here. It's not just from there. Not just from there. It's from all these sunspots. So that's pretty interesting. So I'll keep you up to date on that. I've been your host, Stefan Burns. Smash that like button, help the channel grow. Please subscribe to the channel if you want to stay up to date with what is happening energetically. It's earthquakes, volcanoes, geostorms, severe weather here on Earth, also solar activity, space weather, planetary alignments and resonances, interstellar and cosmic forces. We cover all that, consciousness, everything, wrap it up together. It's all connected. I make videos almost daily. We are now going to do a cosmic connection meditation. If you would like to join in, then please find a comfortable position. We're going to play some singing bowls just for a little bit to help ground ourselves during these energies and to prepare for perhaps what is coming. We have our third eye chakra singing bowl here. I recommend you find a comfortable position and just relax. With all this energy, now is a great time to envision what you want to manifest, to see in the world, for your life to be. Because the sun is here supporting us with that, giving us fuel and energy. We can harness that creatively for self-actualization, spiritual and meditative purposes, for inner discovery, to shine our light to the world. What you focus on is where your energy goes. What you visualize is what you will create in your life. If you're only focusing on your problems, you're only making them bigger and worse. We all have problems. Treat them with respect, but don't fixate on them. Do what you need to do to solve them. Apply your consciousness. Create the world that you want to live in. Breathe. Breathe deeply. We give our thanks to the trees, the algae, the plankton for the oxygen. We give our thanks to the earth and the cosmos for our water. We give the thanks to the plants and animals for our food. We are all one. It is time for us to collectively break through. The time has come. I want you to visualize a baby bird in a nest, stretching out its wings it's never flown before, standing there on the edge, 50 feet up, 60 feet up. It knows it needs to fly. There's no parachute, there's no net. This is real life. It jumps. It beats its wings furiously and it succeeds. Or at least it glides. You have to trust yourself. But when you know the nest is too small, your structures no longer support you, and it's time to go, you just simply have to have faith. To suspend your mind, place your trust in God and in yourself. And a great place to be just in general is to be grateful, to have a mindset of gratitude. There's always something to be grateful for, even if you have to roll it all the way back to thanks for the oxygen, thanks for the food, thanks for the water. Because you're not alive without the oxygen. You're not alive without the food. You're not alive without the water. So we can all be thankful for that. We are all given the same 24 hours every single day. You can be grateful for that. And by reformatting your mind to just some of these default positive patterns. You can start to eliminate these loops of worry and making your problems bigger than they are. Problems beget problems. Instead, creativity blossoms new creativity. Every plant that flourishes under your care generates a whole bunch of seeds and creates more. So that is the world that we are moving to, or at least that is a world that we can move to if we work together in coherence, in unity, in love. And that's the world that I want to see, not one of lower expressions, but of higher expression. So thank you all so much for joining me. There's nothing to be afraid of as it relates to what's happening right now with the sun, the planets, the stars. If there really is something crazy, like a big super flare or something, I will let you know. We don't have any of those sort of conditions right now on the sun, but that doesn't make these events insignificant. This is an increased energetic push on our planet. We get these. We've had a bunch this solar cycle. We will continue to get them. And all of them are opportunities to do the things that we just discussed, to make the change, to help other people out, and to help the Earth out. So that's why they're significant. Maybe it's a small solar storm that gets you to do the big thing. I don't think we need the most intense, volatile things for us to finally trigger the change. Let's apply some consciousness. And I always say, guide me, but just please do it gently. And if you listen to spirit, you listen to your inner guidance, the path can be gentle, but also deeply transformative and very liberating. So I wish all of you the best with that. We will continue to do the things here on the channel. We don't just talk, we actually do. And yeah, I'll see you all very, very soon. Please take care of yourselves and have a great day. I've been your host, Stefan Burns. Thanks so much.